Looks like we're live. Hello everyone and welcome to yet another recreational programming session with Mr. Azuzin. Let's make a little bit of announcement and officially start the stream. Hello, hello. Let's do red circle live on Twitch. And what are we doing today on Twitch at a television website? Today we're checking Crossterm Rust library. How about that? So, library review. Haha. But you didn't expect that shit to happen. So I'm gonna give the link to where we're doing all that. HTTPS twitch.tv/tsoding, and I'm gonna ping everyone who's interested in being pinged. There we go. The stream has officially started. So in fact, today we're gonna continue working on for@, which is the simple multi-user chat application that we started to develop like 3 streams ago or something like that. And the problem with this chat application is that it doesn't have a client. It has a server, right? It has a server, but it doesn't have a client. So far we were testing it over Telnet. So let me actually demonstrate what I mean. So I'm gonna do TeamUX and let's go to for@, right? So it doesn't exist. Oh, because I renamed it to hat. Okay, so yeah, I completely forgot, right? Because you can start the Rust packages with for, right? So let me actually fetch the latest changes. So I think I didn't do that right before the stream, so let me quickly do that. Hello everyone. Welcome. So we're just fetching some source code. So and let's merge origin name, right? And we have the latest thing. So you're supposed to run it. So for now, we don't have any proper authentication, right? So it's going to generate a special authentication token that then we'll have to copy paste into this thing. So this is a Rust project, so be patient. That means it needs some time to rebuild, especially for the first time. So yeah. Right, there we go. So we don't have a proper authentication yet. So basically what it does, it just generates a random number and that becomes a token. So you can give it to some clients and the clients will connect. Right, so you literally use Telnet, right, 127.0.0.1 and port 6969, right? So it asks you for that specific token that the server generated. You give it the token and there you go, you can chat. You can say hello. So it doesn't really have any particular interface and that's the problem, right? So you can actually connect from a different place now, right? So I'm not sure if you, how well can you see all of that, right? So maybe I can even do it something like that, Telnet 127.0.0.1 and 6969, right? So you also provide the token in here, and when you say hello in one place, it will also tell it in here too. So as you can see, so you can have a test and stuff like that. So simple, you know, chat application, very simple one. So it's basically, you know, single consumer, multiple publishers, the kind of thing, right? So let's actually close all of the connections. And since we don't really have any particular useful interface, it is very inconvenient to use, especially when you have a lot of people. So what I want to have instead, right, so I want to have a console application, at least for now. I'm not sure if we're going to go to the GUI, but maybe we'll go into the GUI at some point. I want to have a console application that takes up the entire screen, right, and one line, one row, the last row is reserved for the user prompt. Right, is reserved for the user prompt and it never changes. And when this kind of client receives new messages, it just appends it to the list above that prompt without disturbing the prompt or anything like that. So we need the basic functionality like that. So that means we need to have a lot of control over the terminal, right? So we need to have a lot of control over the terminal. And one of the libraries I heard people are talking about in the Rust community is called Crossterm, right? So there's been a lot of different terminal libraries throughout the history of Rust. They pop in and they fade out constantly because it's Rust, right? So as of right now, at this day and age, people use Crossterm. I have no idea for how long my application is going to survive if it depends on Crossterm, but it's just a client anyway. It's just a client anyway. So let's just give it a try. Let's give it a try and see how well it performs. It actually solves our problem. So for now, our problem is very simple, it's very straightforward, and we'll see if it actually will solve it. So anyway, let's go ahead and do that. I already actually exited the chat in here. So I plan essentially to have two executables within the project, right? So in cargo, we can specify one executable. I suppose to specify the second one, what we have to do, we have to say something like this, right? So we have a server and we have a client, but we don't have this file yet. We don't have this file yet. So let's go ahead and maybe create that file. So this can be client rs. And let's just write a simple hello world. So hello from client. There we go. So let us see what is going to happen if we try to build this. I never actually worked with a project with several executables, so I'm not sure how it's going to work. Right, so if I do run and I have several, okay, so cargo run could not determine the executable, the binary to run, use --bin option to specify the binary. Right, so variable binaries client and server. That's actually very cool. So if I do bin client, there we go, hello from client. And if I do server, it will run the server. So we have two executables within the project. Pretty cool, pretty straightforward, pretty nice. So let's do the first thing that we would like to do. Let's add Crossterm as a dependency. All right, not that many dependencies, so let's try to build the entire thing and see for how long it is going to build. How many new oh, it's not that much actually. It's pretty small. Parking lot. Huh. It also depends on ring. Huh. Oh wait, no, it's not. We are depending on ring from Russells, right? So we're using Russells. We don't really do encryption yet, but we already depend on Russells just in case, right? Because we're going to be using that. Small vec. Small vec. That's a very interesting name for a package. Let's take a look at the tree of the dependencies. That's a pretty small tree. No, it's not that bad, actually. It's not that bad, especially if you take a look at the Crossterm. That's reasonable. That's very reasonable. So that's pretty cool. All right. So let's generate the docs, right? Because we're going to be learning, you know, Crossterm from the docs. So it's generating documentation. So it will generate documentation for all of the dependencies as well. I should have maybe supplied the --open flag so it opens the browser automatically as it stops, you know, generating things. But I can do that one more time. So cargo doc open, and I suppose it's not going to do that the second time. It's not going to rebuild things the second time. So here are all of our crates that we depend on, and here is the Crossterm. So there we go. So here is the documentation for all of our dependencies, and it's local. Crossterm is a pure Rust, that's actually pretty cool, a terminal manipulation library that makes it possible to write cross-platform text-based interfaces. See features. Okay. It supports all Unix and Windows terminals down to Windows 7. Not all terminals are tested. See tested terminals for more info. I don't really care. This crate supports all Unix and Windows terminals down to... Okay. I got it. Okay, it supports all Unix and Windows terminals down to Windows 7. You don't have to tell me that twice. Sure. Okay, let's take a look at this thing. So the features, right? So this is basically the features that you have. Oh, okay, it was an anchor, right? It was apparently an anchor, so I'm supposed to just click it, and it refers to the section features that doesn't exist. Right, so it refers to features. It doesn't exist. Nice library. I mean, nice documentation. Maybe library is good, I don't fucking know. So, command API. So, the command API makes the use of the Crossterm which much easier and offers more control over when and how command is executed. The command is just an action you can perform on a terminal, for example, cursor movement. Okay, blah, 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 cursor. So lazy execution. We have examples. Would you look at that? We have some examples. Simple demonstration that shows the command API in action with the cursor command. So we import the usual standard stuff. Then we import queuable command and cursor. Okay. So, and I suppose queuable command is maybe implementation of some sort of interface for the std out, right? Because now it extends std out with this kind of thing, right? Because std out by itself, as far as I know, doesn't have this kind of thing. Right, so, and you queue essentially the command. So they improved the performance by batching the command. I see what they do. So they have a batcher. It's a batch renderer for terminal. Do you guys know what is a batch renderer? Like in graphics and stuff like that, quite often people implement that for game engines, like with OpenGL. Right, so because in OpenGL, each individual draw call could be slow. So because of that, what they essentially do, they create sort of like actions that your renderer can do, and they do not perform those actions right away. They accumulate those actions into one bigger action called batch, and then they render the result once, like all at once, right? So, and yeah, that's basically it, but for the terminals, right? For the terminals. That's kind of interesting, and that's why it's queued, I suppose, right? So they reinvented the already existing concept, but since they didn't know that concept existed, they came up with its own name, right? So, right, they could have actually called it batch renderer, right? So, but it's queue command. Maybe not. I don't know. Maybe they know about batch renderer. So. Okay, so, and here we can move the cursor and stuff like that. So the most interesting interface, I suppose, for us is queuable command, right? So it is a queuable command, a queuable. How do you say that? You have to add the A. Can your French do that? Can... Is this really English? I'm not sure. I think Q is also a French word, isn't it? So I'm pretty sure it's a French word. It must be a French word. So, and what do we have in here? So who implements this kind of things? Anything that is writable will implement this thing, and it just has one method. Okay, so what they did, they just extended the writable interface. All right, good enough. So what kind of commands can we have in here? So Crossterm command, it's a trait, but who implements this kind of trait? Okay, so here are all of the implementers of this trait, of the command trait. So, and so what they usually are, I suppose they're usually structures. Okay, I see how this entire thing works. I can read this entire thing as an open book. It's pretty straightforward, right? So let's go ahead and try to use that. Okay, so let me see what we need in here. So we're gonna import the standard things. So here are the standard things, the write interface, the stdio. That's pretty cool. So now we also have this thing. So, and the cursor apparently is sort of like a separate package. I didn't realize that, by the way. So cursor, oh, some of these commands are probably in those separate packages. Yeah, okay, move down and stuff like that. So how many of such commands do we even have? So the cursor, event, style. So if we take a look at the event, there's so essentially some like key down or mouse events. Not bad, not bad, not bad. Okay, so I'm intrigued. Even mouse events, and all of that is cross-platform. So all of that is cross-platform. Okay. So the first thing we need to do, we need to sort of create the std out, right? So we're sort of locking it, and then we're moving this entire thing. We're moving this entire thing to 5.5, whatever that's supposed to mean. One of the things we can do, we can actually print hello world, and then we can move the cursor to 5.5, and then we can quit and see what is going to happen, if anything is going to happen at all. Let's first try to build it. Okay. So as we can see, write is not even used, right? So it's an unused import, so we can just do that, which is surprising to me. And on top of that, queue is a thing that may fail, right? It may in fact fail. So let's maybe return a result. I don't know. So what exactly do we want to return? So error is one of these things. So usually people return box. I don't want to do that. So I'm gonna map error, and I'm going to just, let's actually unwrap it. You know what? Unwrap it. So we're just testing things. We don't need to develop like a, you know, high availability software in here, right? So we can crash, right? We can totally crash in here. So that's totally fine. So enqueuable command is also, why do we have to import all of these interfaces if we don't ever use them? Example, what the fuck is wrong with you? And by the way, I'm an idiot. I'm supposed to actually unwrap this entire thing. So, and you still need, okay. Why did you tell me to remove this entire thing if now you require me to add this thing? What the fuck is wrong with... How is that fucking helpful? I swear to God, the warnings confuse you even more than actually help you. Finally. Excuse me. Alright, so let's actually try to do run bin client. And is this the cursor? Is that 5, 0, 1, 2, 3, 4, 5? Okay. And why did it go here? Ah, I see. You know what I'm thinking? I'm thinking that it actually was somewhere here, but once it quitted, it forced it to go to the right. And that's how it happened. Okay, so that is kind of understandable. We can actually confirm that by adding a little bit of a sleep, right? So we can do std thread, right? So here is the thread, and we can sleep for 5 seconds or so and see where the cursor is going to be. I think 5 seconds is going to be enough to actually figure that out. That didn't work because we have to provide the duration. So can we also do duration? I think Rust allows you to do some weird goofy ass shit like this, which is equivalent of importing that and that. Do I understand correctly, Epic Roosters? Do we have any Epic Roosters in the chat? Right, so I suppose you can do goofy ass shit like this, right? So you can do it, and that's basically what it means. Okay, so Epic Roosters actually confirmed that. Alright, so it doesn't fucking... Oh yeah, I forgot to actually use this thing. So, duration from sex. And it's a private struct. Wait a second. Ah, for a second I thought that it's in there, so it's actually in time. I'm sorry, I apologize for my ignorance, of course. There we go. So let's actually try to run that, and it didn't do shit. Alright, so to be fair, this kind of command is not particularly representative of what the fuck is going on. It is not particularly representative, so we want to do something more interesting. So one of the things apparently we can do, we can actually clear everything on the screen, right? So we can clear everything on the screen. So I want to bring back the place where we had the list of all of the commands. Okay, so that's actually very convenient. So here's the clear, and we can do clear type. Clear is within the terminal, all right? So and you can clear, so you can do all, and you can do purge. That's very interesting. So all is all cells, and purge all plus history. Whatever is that supposed to mean? Like, it's not helpful. Right, so I suppose the first thing we want to do, if we're going to be like making like an interactive application or something like that, we want to clear all. Right, std out q, clear, so terminal, clear. Clear type all. So, and also another interesting thing. So can you chain the queues? Can you chain the queues? So what does queue return? It just returns the result. So you can't really, no, it's just a command. Yeah, you, ooh, all right. You can chain them. You can chain them. Sodium, you didn't flush. Oh, you mean, okay. So, yeah, so essentially what I need to do, I need to flush the STD out. So, is there, yeah, okay, so I can see that, so I forgot to flush. That explains. Thank you so much. Thank you. All right, so, and flush is not a method of std out because it's a method of writable, and that's why it didn't complain about not having like writable. All right, so that's basically what's going on, and this entire shit may fail as well. Right, there we go. Okay, so let's just try to write. Look at that. Thank you for reminding me to flush. Always flush after yourself, chat. Respect the other people. Always flush. Yeah. The chat is full of professional flushes, exactly. So we even have an emote for that. It's a Sodium flush, by the way. It's available for all of the subscribers. So if you subscribe, you can use this epic emote. Isn't that cool? I actually drew it myself. Seriously, I drew it myself completely. Just for you. Sodium flush. All right. So that's pretty cool. All right, so we'll keep that in mind. So that means the MoveTo actually works. So what about the clear? So if we try to clear the terminal, what is going to happen? So it doesn't even compile properly. So okay, so Crossterm terminal, let's do that. Do we need to add anything else? Clear type. So I suppose, you know what? Let's actually just import everything that we may ever need. So this is going to be terminal, then clear all, because why not? Why not just allow you to use things like that? It's going to be shorter, it's going to be more concise, it's going to be more readable, and everything, the usual things, you know? So clear all is not in the terminal. Seriously, where it is? It is in the terminal. No clear all. Yeah, because you don't have to do that. It's a clear type. I see what you mean in here. There you go. So, yeah. stdq unwrap. Are you happy now? You seem to be more or less happy, so I'm gonna do that, and it cleaned everything. So yeah, we know how to clean the screen. Isn't it poggers? I think that's pretty poggers. So okay, so what other commands do we have? So can we get the size of the terminal? I think that would have been kind of useful. So you can set the size, but can you get the size? So isRow enable blah blah blah. So maybe there's some more examples you can. Okay, so there is direct execution. Okay, so for manipulation it is not all important to be efficient with flush operations. For this use cases, then execute command. Okay, so we can execute it directly, so that's kind of cool. All right, so terminal, you can clear the terminal, you can move X blah blah blah. Style, you can print with style and everything. All right, so overall I do understand how this entire thing works. So I'm really curious about TTY. So with TTY you can just check whether something is TTY. TTY, why is TTY? But how can I? Oh, I think I know what potentially can tell us the size of the terminal. It's the event loop, because you have resize. That's right, because you have resize. That's something that's going to be very, very much useful. So people say there is a terminal size, and I wonder, is that true, or is that one of these things that people literally confabulated? So how much you guys bet that this is true and how much it is confabulated by ChatGPT? So people say it is true, real. Okay, let's find out. So we can always just go to terminal. Right, so, and what kind of functions do we have in the terminal? Oh, there is a size, look at that, it's actually true, holy shit! What the fuck, it's actually true, what the fuck, oh. Yo! So, chat telling the truth. Chat actually telling the truth, holy fuck. Also, let's import self, And one of the things I would like to do, actually, I would like to take the terminal size, right? So it's going to be terminal size, and what we get in here, we get width and we get height. Where did that shit come from? Anyway, so all right, so we have width and we have height, and then I can move the cursor somewhere. Crossterm cursor and MoveTo. So this is one of the things I want to have. So let's actually import self and MoveTo. And we can move to, let's say, center of the screen. Right, we can move to center of the screen. So std out q MoveTo, and the center of the screen is just a half of the width and half of the height. It's that freaking simple. So how do you calculate this, like the center of this thing? It's just half of width and half of height. Can your CSS do that? Can you just center an element in CSS as easy as that? People say yes. I don't believe you, actually. Though it was said by a person who actually predicted the function name correctly. So this is a very good language model. So I think we can trust this language model. Right, so so the answer is yes. All right, so yeah. And then what we can do? We can probably print something. Is there a command that prints a text? I suppose what you do, you just like write the text you want to write in there. Right, so you just say your mom, right, and that's it, and you just text. So yeah. So let's see. So here we're gonna do unwrap, and here we're probably also gonna do unwrap. So on all of these things we'll need to do unwrap. So let's go to the compilation errors. What do we have in here? So self is unused. Okay, you're being annoying like that, mother flipper. So this is unused. It's probably gonna be used. Okay, so I'm gonna just ignore all this shit. Fuck that. So this is the result. Okay, let's unwrap this entire thing. Thank you, compiler, for telling me that. Right, isn't that cool that the statically typed compiled languages actually tell you what you have to do? I think that's actually pretty cool. So we can take these bytes. Right, so we can take these bytes, and so I think it's not bytes, it's as bytes, if I remember correctly. Yeah, there we go, it's as bytes. So did it? Okay, so that's basically it. So let's actually try to do that. And your mom. To be fair, it would be cooler if it slept for 5 seconds or so. Thread sleep duration from sex. Duration from sex. Right, so 5 sex. So we're gonna have 5 sex with your mom. Okay. So to be fair, I think your mom is not really centered properly for 5 sex. So what we probably want to do, we want to take, let's factor out your mom into a label, right? So we're going to have some sort of a label in here. So this is a label. And so, yeah, people are saying that you can put B in here, so sure. One of the things I want to do, I actually want to move minus half of the label length, like so. So you see, actually it has to be on the width, right? So we center in horizontally, right, taking into account the length of the label, and vertically with just height. Vertically with just height. So let's actually rebuild. So let me see what is going on in here. Label, but found use size. Okay, so I mean, I can always just say as U16, will you accept that? It will accept that. I'm really happy. Okay, so let's try to do that. And I go, here is your mom, perfectly centered. Here is your mom, perfectly centered. So it's pretty small. So let's actually adjust it to the real size of your mom. So let's make it bigger, right? So that's a little bit closer. And look at that. There we go. So that is centered perfectly. Okay. Let me see. So I feel comfortable with this library. So this is literally my first impression with this library, and it's okay. It's basically in cursors, right? So it's just like a slightly different API, but the concepts are the same. The concepts are basically the same. So I suppose I can work with that. I can in fact work with that. So the first thing we probably want to do, we want to implement a simple chat UI. Right, so we're going to split the screen into essentially the main window that contains the messages and the prompt where you type your text, where you type your little text. I pray stop teleporting my mom from her bed to your terminal. I'll think about that. You'll need to subscribe for that, for me to stop doing that. All right, so I suppose one of the things we'll need to be able to do, we'll need to have an interactive application. And an interactive application, I suppose, actually handles the events, right? It actually handles the events. So let's go ahead and see how you're supposed to organize the event loop, right? So you just organize an infinite loop. One of the things we do in here, right? So we essentially import this thing, this special thing. Let's just put it in here somewhere, and we just constantly read. We simply constantly read. So we can even do something like while. So essentially it should never actually break. Blocks until event is available. Okay, that's a really weird way of doing that. Let me take a look at what exactly returns, what causes error in this specific case. Oh, you can even have This is exactly what we'll need, chat. So this is one of the challenges with implementing this kind of client, because we do need non-blocking events. Because, for example, will need to be able to render the messages as they come in without you interacting with an app, right? Without you interacting with an app, and this is something that we will need for sure. Right. So let's take a look at the poll. So poll checks if there is an event available. Right. So you can do a timeout, right? So you can check whether the event is available, and only then, if it's available, you can read it. So one of the things you can do, right? So you are in the main loop, and then while poll, right? So poll returns result, right? So essentially what you have to do in here is just like unwrap, you do poll, you have to specify the duration. Maybe you can do from sex 0. Is there a duration that says like none or empty or like something 0? Yeah, there is a duration 0. Finally, they introduced a new 0. Right. Now you don't have to remember that stupid sign, right? So you can just use human readable names for numbers. Isn't that poggers? That's the user friendliness we always wanted. So while poll is true, right, what we're doing read and also unwrap this entire thing, and then we can do match, and this is where we can handle all that, and that basically provides essentially asynchronousness. Right, so you have a loop, you just drain all of the events that you have in the queue with this, right? So you poll, just see, is there any events? Okay, I handle them all. And then without blocking, you can continue rendering the next frame. So here you would render the frame if that term is even applicable in the terminal. Maybe it is. I think it kind of is. Right, so I do think it kind of is. So that's pretty cool. Maybe that's the paradigm we're going to be using here. So that's the paradigm we're going to be using in here. So now And what kind of events can we even encounter in here? So the events I care about mostly are resize and key, right? I don't really care about any other events, honestly. So let's go ahead and just handle those. Event, so resize, so width, height, maybe something like this, right? So let's be a little bit concise in this specific case. So it's not implemented yet, and event key, and this is the key. So let me see what kind of keys we can even have in here. So there is a key event. Okay, that's cool. And you have a key code. Beautiful. We literally have everything. We literally have everything. Okay, so, and apparently it's not just a key, it's an event, right? It's an entire event. It's an entire event. All right. So, and I suppose we're gonna start with knowing already existing size of the window, right? It's gonna be width and height. To be fair, right? So yeah, maybe it makes sense to actually keep track of the resize. I think it makes sense to keep track of the resize, because this operation apparently can fail. Right, but if resize has happened and we received something about it, we know that it's not going to fail because it already happened. So yeah, I think it makes sense to actually do it like that. Can I do mutable like this to indicate that both of these things are mutable, or do I have to do it like that? So really, can I just say mutable the whole thing? We'll see. It would be actually ideal in my opinion if I could do something like that. So then I'm going to do new. And this one is going to be H and H. There we go. So now we have up-to-date width and height of the entire thing, and we don't have to worry about the size failing when we need it, right? So it's always available, it's always up-to-date. So hopefully, if I understand correctly how this entire thing works. So I suppose we're just not going to handle anything yet, right? So I'm going to leave it empty for now. Right, and in here we probably want to render the whole thing, right? We're gonna render the whole thing. So right now we don't really have anything in the chat. We don't really have anything in the chat. So we need somehow separate the main window that we're gonna have in here and the prompt. So what I'm thinking is that maybe we're gonna separate it with like a dash line or something. With like a dash line or something. What do you guys think? Is that a good idea? Is that a good idea? I don't know. So since we don't have anything in the main window, right? Since we don't have anything in the main window, I'm gonna skip rendering it. So I'm gonna actually move the cursor straight to where we have to draw the line. So first of all, obviously, we probably need to get rid of all of that. So this is just your mom and stuff like that. So let's bring all of that stuff. Maybe up, right? So this is the std out and everything. So, and obviously one of the things we need to do, we need to clean everything. Maybe we have to clean everything on each and individual rendering. So does Crossterm actually render the differences? So they say that they are super efficient. Does that mean that I can clean the entire screen on each and individual frame? Right, because if you do that in a raw terminal, you're gonna end up with a lot of flickering, right? Because you clean up everything. One of the things libraries like ncurses do, what they do, they kind of maintain the internal state of the terminal. Then you update, then you put some actions on that internal state, and then it calculates the difference and only apply the differences, thus reducing the flickering. It's like a virtual DOM, but for the terminal. Holy fucking shit. And Curses been doing React before browsers existed. All of the React devs are pissed off. React devs are shaking right now. That's right. And Curses been doing virtual DOM before even Windows existed. And Curses is actually a pretty old library, right? Isn't it? So I think it existed before like graphical interfaces existed. So that means it's a precursor to web, like literally. So you should have seen their reaction to your visualizer. I mean, I've seen them in the comments. Right? So that video, by the way, recently started to blow up. It has like almost 50,000 50,000 views, which is like very unusual for my videos. And yeah, so I can see that. This is actually quite funny. All right, so I'm gonna assume that it does the virtual DOM for the terminals, right? So it does the virtual DOM. So now, what can we do? So how does it index the cells? How the cells are indexed? Are they indexed from 0 or are they indexed from 1? So that's a good question. I want to take a look at the... Let me close everything, so when I have too many things open, it just becomes a little bit overwhelming. So here's the cursor, and there should be a command to move to. So top left cell represented as 0, 0. Perfect. Cool. So now we can work with that. So essentially, we need to do std out q move to, and we're going to be moving to, in terms of x, 0, right? So we're going to be in the left side, and in terms of height, the last row is h minus 1. So that means we need to step 1 up, so that means it's going to be -2, right? So there we go. So this is going to be q. So we move there, and now we need to fill this thing up with dashes. Is there something that could help us to do that? So is there something that could help us to do that? So where is the command? Okay, so let me take a look at the list of all of the commands. So there's a height. Maybe there's something like fill. I don't know. Probably not. It's probably something that we'll have to do ourselves. The easiest way to do that probably would be to just for 0 to width and just keep doing std right or something. Right, but what kind of stuff do we have in there? So rust up doc open. Right, so I think it's without open. I'm an idiot. Right. So API. Let's take a look at the API. So what do we have in the right interface? So it's going to be IO interface, I suppose. You can only write like a whole buffer. You cannot easily write a single thing, though we actually catch a moment. When we resize the thing. So we can basically maintain some sort of a string that has the bar that we want to draw, and every time we resize, we update this thing, right? So we could have something like bar, which is a string new, right? So it could be mutable, so it is going to be updated every time. And what's the easiest way to actually assign this kind of bar? Can you do that with a format? So I don't remember how to use format. Rest format repeat. So let me see. I didn't really know the syntax. Fill string with repeated characters. Okay. Can you repeat like n times? That's a very interesting question. Okay, so, well, this one is also kind of... str repeat. Okay, this one sounds interesting. I really like that one. So repeat. Look at that. str repeat. Yeah, boy. And it returns string. It's a part of str, but... Okay, that's actually perfect, believe it or not. So, str repeat w, and yeah, Is there like that? Okay. But is there something for bytes as well? Right, something for bytes. Because we'll need that in bytes probably. But yeah, so and essentially what we can do, we can just do write bar as bytes and simply unwrapping here. So that's basically it. And we probably need to move the cursor now to down, right? So it's going to be H1, like so. And then we do the flush. So we just do the flush. So that should be it, essentially. Though, we have a little bit of a busy looping in here. Right. A little bit of a busy looping. So we probably need to sleep for a little bit. So let's actually sleep for, you know, maybe for sex, but as F32, 1 over like 60. What's the 60 FPS? Does anybody remember? 1 over 60. Oh, okay. So maybe it's going to be msecs and it's going to be 16, right? So milliseconds, 16 milliseconds is 60 FPS, right? So we're going to be rendering our terminal application in 60 FPS. Is that good? Maybe 30. Maybe 30 is going to be better. So where's the Python 3 130. So 33 essentially. We can put 33. So that's basically it. So this is an interactive application. This is an interactive application. So now, if I try to rebuild that, let's go to the compilation errors. Let's go to the compilation errors and see what we have. So, oh, all right. So apparently this is such a common mistake that they even added a help in here, right? Because you won't even believe that this is how you have to do that, right? So you can have one thing mutable and another thing not mutable for whatever reason, right? So what else do we have in here? So poll is not available. Poll is part of the term, right? So I'm gonna just make a bold as, yeah, it's probably event, right? So this is an event. So what else do we have in here? str repeat. So is that because, so function expected 2 arguments. Because you have to specify what exactly do you want to repeat. Oh, it's a method of some. Okay, repeat. So this is not how it works. I'm an idiot. So you're supposed to do something like this. Yeah. I'm really happy that the compiler just told me that. Isn't that poggers that you have like a compiler that tells you this kind of shit? I think this is absolutely fucking poggers. What's the next thing? Okay, I mean, just convert it to usize. All right. So msecs. So it doesn't have milliseconds. Okay, so let's actually search for like what kind of methods do we even have in there. Duration from millis. It's not msecs, it's millis. Did you guys know? Millis. And it takes U64. Okay. All right, so there's some other stuffs, and so not everything is handled, right? Not everything is handled. So for the rest of the things, we basically gonna ignore all these things, right? So we only care about resize and potentially the keys, right? Potentially the keys. And there we go. So event is not even handled yet. We're gonna handle it in the future. There we go. We went through the compilation errors, and now we potentially have an interactive applications we don't really fucking know. So let's actually go ahead and run this thing. So let's actually reduce it, right? I'm gonna do cargo run, and let me see what we have. Cargo okay, so I have to specify bin client. It's like bin chilling, and I can't see scheiße in dismissed. So it didn't work. Writing shit into that thing literally did not work. I wonder why though. Because I'm an idiot. Yes. There we go. Look at it. And it updates accordingly. it updates accordingly. Right. I can't really type anything into it. I can try to type something, but it doesn't allow me to do that. But yeah. So this is the simple. We need something more interesting. This is kind of dumb. Can we have? There are some. I can't select chat, by the way. It doesn't allow me to select chat because it's constantly refreshing. And maybe this is something where we have to, you know, implement the mouse moving and stuff like that. So yeah. So that's pretty cool. That is pretty cool. So, and we can chat. We can implement something very epic, I think. We can implement immediate mode rendering, right? Immediate mode rendering. So essentially, right, we're gonna have the main window, right, and the input and stuff like that. And all of them are going to be sort of separate components that you call and they do the thing. So they're probably going to be accepting the std out. They're probably going to be even accepting the queuable command, right? Maybe queuable command plus, right? But I think queuable command kind of implies that you're also writable, right? Because it's extending this entire thing. So let me take a look at this thing. No, it's not really extending. So you're just implement. Okay. So yeah, queuable command for t, where t is writable and also size. But I don't remember what question mark means, but I mean, whatever. So if I have components, right, something like chat window, I can basically accept this thing as an implementation of queuable command, right? Maybe mutable implementation of queuable command, and that is going to be abstract enough, right? It's going to be abstract enough, and it will also include all of the write commands and stuff like that. All of the write commands and stuff like that. This is so funny. Like, we found very simple and straightforward solution to the problem, and Rust developers be like, why not this monstrosity all of a sudden? Seriously. Like, this is the most straightforward, readable solution. You have a thing repeated n times. And then we have Rust developers. Because it's not cool enough, it's too readable, yes. I swear to God, Rust people. I swear to God, Rust people. That's literally exactly why everybody laughs at you. That's literally exactly why. So you have a good solution, good, readable, simple solution, and you're suggesting that. That's not serious. Come on. That's not serious. So does anybody remember? So there is sort of like an ASCII thingy that actually connects perfectly all of the cells. How is it called? Right. So this kind of thing. So there's ASCII characters for like UI or something. So I don't remember their name. So ASCII boxes maybe. Right. So let's actually go for Google. So box drawing characters. That's probably what we need in here. Box drawing. Okay. All right. So okay. So let's just grab this thing and replace that stuff with that. So hopefully that will connect perfectly. And we're gonna just rebuild this entire thing, and boom! Look at that beautiful line. Look at that smooth, beautiful line. Holy shit! You can see the seams. Unacceptable. Like, why there are seams in there? It's not perfectly flushed. It's not pixel perfect. The fuck? Can we just do something like this? There's a big X in here. All right. Maybe we can even do so bar char and just put it in here. Bar chart. Bar chart. Yeah, semicolon. Imagine asking for semicolons in 2023. Okay, look at that. Look at that. And the shed is also not perfect. Like, why? The fuck? Right. Anyway. So what's going to be the next thing? We need to handle input fields somehow. Right, I suppose we need to handle input fields somehow. What I'm thinking is that we can just go ahead and handle events and look for the ASCII characters. So where is the cross term? So event, I want to find the definition of the event. So here is the event. Key event. So there's a key state, represents extra state. Probably don't really care about that. So here's the key event, and you have key code, and do so. Okay, so here are the. Oh my god! Thank you so much. But okay, so I don't have to do shit, right? I can just take the character. Okay. So what that means, I can have a prompt, which is a string, right? Every time event code, was it code? I think it was just code, and I can just match that goddamn code, and within the code we have key code character X, and I can just push that thing into the prompt. Prompt push X. Look at that. Look at that. Isn't that beautiful? So if we see something else, we're gonna ignore it for now. So that's totally fine. And then at the bottom, when we went in here, so here we're just drawing the bar. So this is the bar, and here we can try to render the prompt, right? So we can try to render the prompt. And I'm gonna do QQ, and actually not QQ, just I'm gonna write a prompt as bytes unwrap. There we go. So let's try to compile that. Key code, where is the key code is defined? So it's defined within an event. So let's do key code. So what do we have? So prompt is not mutable, so let's actually make it mutable super quick. And now, are you ready, chat? Fuck. Oh. Ooh. That is very interesting. So we need to, yeah, cooked. This person knows what's up. They even use like a correct terminology. More or less. I don't know, is that like official terminology for the terminals? But yeah, in the terminal world, there is this slang for like terminals. There's a raw terminal, and the opposite of raw is cooked terminal, right? So, and in this specific mode, we cannot be super interactive. So we need to switch to the raw mode, but I expect that the cross term allows you to do that easily, right? Does it allow you to do this easily? I'm pretty sure it does. So because we have a terminal thingy, right? Terminal package. So let me go somewhere here. So this is the terminal, and I'm pretty sure it has something. Enable raw mode. Okay, so let's go ahead and do that. Enable raw mode. Yeah. So we take the terminal size. Maybe it will make sense actually to terminal enable raw mode. Gotcha hyper. There we go. And then I'm gonna just ignore this entire thing. So let me see. It seems to be compiling. And chat, are you ready? Look how reactive this shed is. Look how reactive the shed is. We can't do backspace. We only can actually append things in here. We can't really do much. When we press enter, nothing is gonna happen, but we can try to handle them. The moment I realize that I'm fucked, I'm pressing Ctrl+C. So okay. How is it called? Client. It's actually grippy P. Okay, kill all client. Bam. What can we do in here? That's a very interesting. Why don't you handle Ctrl+C, motherfucker? We can try to handle. So there should be some modifiers. Key modifier. Okay. And one of the modifier. So. So it's a struct. And it has methods. And it has contains. Whether all set bits in a source flag value are also set in a target flag's value. So yeah, you can check for the specific thing, and then okay, so you can see if the modifier contains control, for instance, or something like that, right? So, and in here we can quickly do that. So essentially, if x is equal c and event modifiers fires contains, so, and key modifiers contains key modifiers control, then let's introduce something like quit, while not quit. And what we do in here, we just put true in here, and there we go. Simple as that. So use of an declared key modifiers. Okay, so let's. I'm gonna assume that it comes from here. And who needs POSIX signals? Who needs POSIX signals if you can just handle Ctrl+C? All right. Just handle Ctrl+C. It's that fucking simple, mate. All right. So essentially, we can now do a pretty cool thing. So we have a state which is prompt and stuff like that. We can introduce like a chat, which is going to be a vector of strings, right? So you know where it is going. You know where it is going, right? So now we can try to handle enter, right? So when we do key code, there is an enter in here. So we can do key code enter, and I can go in here, and essentially I can do prompt push, actually chat push prompt, but we have to make a copy, so we'll have to clone this entire thing, and there we go. And after that, we need to clean this entire thing. Can you just clear or clean or something like that? I think you should be able to, right? So, and now every time we press enter, we sort of append a thing into the chat. So, but we need to actually render that somehow. So essentially, so here we render the bar, here we render the prompt. So what we need to do, we need to iterate through all of the lines in the prompt, in the chat, right? So for a line in chat, so we probably have to do something like iter, right? So we do something like iter. And now, essentially, we need to move the cursor to the corresponding row, but to know the corresponding row, we need to enumerate each individual line in the chat, so we know the row where to move. Right, so this is going to be something like that. So here is the row, we're moving into that row, and then we're writing the value of the chat, the value of the line. Right, but we have to do that as bytes, of course. We have to do that as bytes. And there we go. So I know that I don't check the bounds. I know that. I do that intentionally just to get something working already on the screen, right? So we just do that, and that should be it, actually. That should be it. So let me see. So as U16, so that is understandable, and then we go That's pretty cool. Chat, are you ready? Are you ready? So there is a little bit of a problem. We don't reset the state of the terminal, but it doesn't matter. Are you ready, chat? First fucking try. Easy peasy lemon squeezy. It's that fucking easy. It's that fucking easy. But of course, we don't really like reset the terminal. Look at it. So we have to disable the raw mode, right? By the way, if you're stuck with the terminal in an incorrect mode, just blindly type reset. I just blindly type reset and press enter. And it will work and it will reset the terminal, right? Just in case, right? So if you ever get yourself into this kind of situation, just reset the state of the terminal. Right. We already have a base of the chat application, chat. So yeah, it's pretty cool. To be fair, it's not that revolutionary. This is literally the experience you would get if you use ncurses, for instance. This is basically ncurses implemented in Rust, right? It's just like ncurses implemented in Rust. That's what it feels like, right? But it's a modern one, and also it supports Windows. I mean, ncurses. There is a version of ncurses for Windows too, so it's totally fine. Anyways, so I suppose I know that in the terminal, right, there is disable raw mode. So that's what we can do. So when you do escape, we can do terminal disable raw mode, and it can fail. I'm gonna make an assumption that it fails, and I'm gonna try to compile that, and yeah, apparently it can fail. Look at that. That's pretty cool. So that means if I run this entire thing, do this kind of stuff, and then Ctrl+C, it's totally fine. So it resets the state of the terminal. It resets the state of the terminal. It's pretty cool. Okay, guys. So, but there is a little bit of a problem in here. So let me demonstrate you. There is a tiny bit of a problem. Ooh. But yeah. So the problem is, it actually goes out of bounds, right? It goes out of bounds. So we need to limit it somehow. Right, we need to limit it somehow. So let me see. So essentially we have the size of the chat window, right? So we can even say something like chat window height, right? So this is a chat window height. To be fair, honestly, I would love to maybe have a notion of the rectangle, right? So have a notion of the rectangle. So struct, let's call it rect, and the rect is going to be x, y, w, h, and all of them are going to be u16. And essentially we can have a chat window, right? So chat window that accepts stdout as a queuable command, a mutable pointer to implementation of a queuable command, and a boundary, right? So we're going to accept rectangle as a boundary, like so. And what this is going to do is going to just render this entire thing. It is going to just render this entire thing within the boundary, but there is a little bit of a problem in here. With the state of the chat window, because the chat window probably should have some sort of like a scrollable state. But I think what we can do, essentially, we can simply render only the last n things, right? So n is boundary height, right? N is boundary height. So we're only gonna render the last n things. So, and I wonder if there's easy way to do that. So in here, we're gonna accept not only boundary, we're also gonna accept the chat, and we can accept it as the slice of strings, right? So this is going to be slice of strings because we have a chat as the vector where we append things, and this is going to be slice of things. So is there a function that acts like an iterator but takes the last n characters, or not really, right? So essentially we have two situations. If chat length is less or equal than n, or maybe we can just directly refer to as height. We can just draw it as it is. We can just draw it as it is. But if this entire thing is greater, if it's greater, what we have to do, we have to take chat as an iterator, right? We have to take the chat as an iterator and drop chat len minus boundary h characters. See what I'm talking about? So that's what we have to do, and that's how we take the last h of them, right? So that's how we can do that. So maybe it would make sense to even factor out this as n, right? So that would make sense. So we don't borrow this in two places. And then we can even just map it, right? So maybe I can do for line in, like so. And when I'm rendering this entire thing, I'm gonna be moving to a specific place, right? So I'm just basically moving to a specific place. Right, so in terms of x, I'm moving to the boundary x always, and in terms of row, I'm moving to the boundary y plus row, and we want to enumerate this entire stuff, right? So we'll enumerate like so. So that gives us the row like this. Maybe we can even call it dy. There we go. So that's basically the dy. That's basically the dy. So that's pretty cool. And yeah, so we need to have this condition because these things are unsigned, so you can't really subtract these kind of things properly. So we are only checking the boundary overflow. We're not checking whether the lines that we're rendering actually fit in there. Right now, we're gonna do that a little bit later, so it doesn't really matter. Though we can kind of already do that, or can we? So I'm pretty sure we can. Yeah, so we can do that through the slices and everything. So we can easily do that through the slices. So what I would like to do right now, I'd like to get rid of this condition. I'll make it a little bit prettier. Right, so essentially we can have m, it's basically how many things you have to drop, right, and if this thing, you drop 0 things, otherwise you drop this amount of things, and then you just do it like that. So we factored out this particular condition, so it's gonna drop 0, right, if it actually perfectly fits. See what I'm talking about? So it's sort of like we could do something like this and say maximum between this and 0, but both of these things are unsigned. Int and is usize, this is u16. You can't really easily do that unless maybe unsigned have some sort of like a special sub, right? If I have usize, do you have sub that returns optional or something like that? So that would be interesting, actually. So usize as a type. I'm looking at the wrong thing. So I need to find usize. So sub assign checked sub. Where is it? Oh, it's loading. Yeah, it's loading the page. Yeah, that's what I'm talking about. Yeah. So it can, that is actually kind of cool. So we can use that essentially. I can say n sub boundary h and it returns you option, and then you can unwrap with default or something. So option unwrap, I don't remember how it is called, unwrap or default, right? So you do unwrap, unwrap or default is going to be 0, and there we go. So that's what we got. So people say unwrap or yeah, so it's just unwrap or, doesn't matter. I mean, I got it right. So that makes it, so it's actually checked sub, by the way. So it's a checked sub. But yeah, so that makes it prettier. It makes it, I'm gonna say that word. Chat, I'm gonna say that word. Get ready. It makes it idiomatic. That's the word everyone masturbates. It's ideal magic. Holy fucking shit. It doesn't solve any problem. It doesn't fucking work. It crashes. But it's idiomatic. Holy fucking shit. Oh. Idiomatic code. What the fuck? Alright, so you see, it doesn't even compile, right? But it's idiomatic. What the fuck? What the fuck? Alright, so what do we have? So is this not how you do that? Really? I mean, okay, can I? You're not allowed to do shit like that in Rust? You can't group several things? Really? You really have to do it like this way, this stupid way? This fucking custom. So, and we can do Resize in here, sure. I mean, doesn't matter. A drop. What is it called, by the way? So let's take a look at the iterator. Iterator, what kind of methods do we have? I swear to God, all of these functional languages, they call these operations, basic operations, differently. They can't agree on how to call this thing. Like one calls it drop, another one calls it your mom, whatever. So what do they call it in here? So there's no drop. There's no drop. Find, flat, escape, ski. Of course, you dummy dum-dum. Didn't you know that famous basic operation skip that literally is called skip in all of the functional languages? Did you know that? Yeah. Anyway, so it's called skip. Okay. What else do we have? So right exists for mutable exists for mutable references, but its trait bound are not satisfied. I see. So the following trait bounds were not satisfied std, which is required by std right. Consider restricting the type parameter to satisfy the trait bound. Where impl that is this. Okay, I mean, sure. Why do you make it so difficult for me to just pass this thing somewhere? Is there like a less verbose way of saying this kind of shit? Can I... Okay. Can I just say plus right? Can I just say plus right, please? You can't do that. Okay. All right. Though, interestingly, we can just accept right, I think. Oh, it has to be T, yeah. But just a second. I think we can just accept right because this extension kind of works for rights too. Yeah, I can just accept right. You all are wrong. You all are wrong. That's the easiest way to solve that. Haha. Okay, so rect is never constructed, so let's try to construct it. Okay, how can we be constructed all that? So let me see. So and this, by the way, is very dangerous because h could be less than 2, right? Less than 2, but anyway. So chat window, let me actually see chat window, right? So this is gonna be that, and I'm gonna just pass it by a mutable thingy. The boundary is gonna be interesting, right? Might as well, actually, I think I wanna put the chat before the boundary, because it will make it easier. Do something cool like this, and here you specify all of that shit. Isn't that epic? it's almost like you're using like this trendy UI framework. Like it's a chat window and you specify the boundaries like that. It's holy fucking shit. Oh my god. Okay, so here this is basically 0, 0, right? So this is basically 0, 0. Width is going to be the same, and height, I suppose height is -2, right? So it's literally this height -2. This height -2. All right. So what do we have in here? So the chat is just basically this. And what do we have in here? So W is never read. I mean, that's fine. Do you yeah, it does in fact compile, right? It does in fact compile. So that's pretty cool. Let me see. So it does in fact compile. So we need to test how well it actually cuts things. Right, so we're gonna do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I can't delete shit. Okay. Right, but as you can see, it does actually cut things out. Right, and it adapts properly and stuff like that over time. Right, so it kind of adapts to all of this stuff. Since we're using these boxes, we can actually put some extra stuff around these things. So I don't think it's going to be that like hard, but we can do that a little bit later. But yeah, so Ctrl+C, and seems to be working. So the only thing we don't cut horizontally, right? We only cut vertically. So let's go ahead and try to do that. So it should be pretty straightforward, right? It should be pretty straightforward because we just need to essentially take, so this is the bytes, right? So this is simply the bytes, 0, boundary H, W, right? But if W is bigger than the amount of bytes, it's not really gonna work. One of the things we can do, let's actually factor out the bytes, like so. Let's factor out the bytes. And let's do a little bit of a condition. So if bytes is less than the or equal boundary W, you just do that. Otherwise, you do it like that. So 0 boundary W. So sorry. Doesn't even fucking compile. Anyway, so this has to be usize. Can I just make this entire thing usize right away? Because yeah, I kind of feel that maybe I should make it even signed, because having signed things like that in here makes it easier to do mathematical computations. But I didn't get there yet. So let's actually start with just using usizes in here. So let me see how to do that. Well, I mean, well, this is a kind of yes. What else do we have in here? So this is the bytes. It has to be a pointer. I feel like slices, I vaguely remember, chat, slices have get, and they return, they accept range, right? So the index can be also range. Yeah, this is what I'm talking about. Look at that. This is what I'm talking about. You can get the range like that, and then you can do some epic hackery, right? So essentially, let's actually abstract away from all of this stuff. You can take as bytes, then you can get from 0 to boundary, boundary WH, right? And then unwrap or use the original bytes. In that case, maybe replacing it with the original bytes like that would be easier. And what we're doing here, right? So can we even, nah. So let's put it like this. And it's going to be just a single line. Is that idiomatic enough? So hopefully it is. So let's continue. What else do we have in here? So as usize. And honestly, we can just keep those things as usize, can't we? But maybe not. Let's actually keep it on that. So as usize. All right. So what do you want in here? Yeah. Okay. So let's have something long. Okay. It does cut it. Yikes. So in case of the chat prompt, we have to do the same thing. We have to do the same thing. Right. So let's go ahead and do that. So as you can see, we're just like implementing something. We're looking at what's broken and we fixed that. So I can literally just copy paste the code that we wrote in there. So something like this. And we can just do it like that. So, so this is the bytes, but the bytes of the prompt though, I can even put that in here. So prompt get unwrap the bytes, unwrapped, and then print the bytes. Like, well, I mean, yeah, that's it. So maybe we could factor out this thing. Oh, this one is very interesting because for the prompt we don't want to show the last one. We want to show the first one. But maybe it's fine. For now I think it's fine, right? So we can refine all of that a little bit later. So slices and indices are type usize or ranges of usize. So okay, so as usize. So now if I try to do that, okay, so it basically, yeah, it goes there outside but doesn't work properly. But I mean, it's fine. It's fine for now. It's fine for now. So we have a simple like window that can potentially asynchronously receive things. And that's actually kind of cool, I think. So one thing we need to be able to do, we need to be able to paste the token. Right. So I remember in Crossterm, there was a command for copy pasting. It's actually in events. Right. So where are the events? Look at it. They literally support copy pasting. That's actually pretty cool. So I didn't see p. Where is the paste? What the fuck? Paste. Enable bracket paste. Huh. Okay. So event paste. Okay, that's weird. So it's just a string. All right. Let's go ahead and just support that. Event paste data. And what we're going to be doing, we're going to be literally just, you know, appending that to a prompt. Can I do prompt push data or something? Maybe pushes. I think there was like a push str. Yo. Okay. Your mom. I'm copy pasting this. Now let me restart, and I'm. Oh, this is not how we do that. But we can actually add support for this kind of commands, like quit or something. So now, honestly, we can already plug it in to a chat. Like we can already turn this into a chat client or something. Like who said we can't do? We can do that basically. So the only thing we need to do, essentially, is just to use std net TCP stream and just keep receiving the data from the server. And then when we receive the data, we can just push it into the prompt and stuff like that. Who said we can't do that? So I think that's pretty cool. So But you know what? I think the time has come to make a small break, chat. The time has come. I've been slapping the good for 1.5 hours. I ran out of tea. I'm running out of steam. So let's make a small break. I'm going to refill the cup of tea, and then we're going to plug our chat application. This is basically like a chat application, right? So, it has a window, right? It has a prompt. So all of the components are in there. So this is the basic chat application. So yeah, we just need to plug it into the terminal, into the network, and it will probably work with the rest of the stuff. So yeah, let's make some break and okay. So let's go ahead and connect to the server, right? So we already have a TCP stream. So the first thing we can try to do, we can try to establish the TCP connection. So do I have this stuff open? So I have only opened, yeah, so here is the global documentation. I can't see the can't see the scroll bar. So TCP stream, I'm pretty sure TCP stream just has a connect method, simply connect method. Zozin, TCP stream when? Today. So TCP stream connect. So, and where are we going to be connecting? So 127.0.0.1.69.69. We're going to hardcode it for now. Right, so I'm doing unwraps because this is a client. Right, so I usually try to avoid unwraps on the server because it has to be like a high availability service, right? So that's why I'm trying to handle errors and stuff like that. But the client, I mean, client doesn't have to be high availability, so let it crash. Fuck that. So, so here's the stream. So we get the stream. I feel like one of the things we'll probably need to do with this thing, we need to make it non-blocking. You know what I'm talking about? So because this entire thing is going to be very much asynchronous, right? So it has to be, you know, off sync with UI, and the stream should be sort of like updated asynchronously. So one of the things we can do, we can just set non-blocking to true, right? Set non-blocking to true and unwrap this entire thing. And of course here, we're going to just do it like that. So now this entire thing is non-blocking, and every time we're reading from it, we are like given, I don't remember what we're given. I think it returns an error. So what does it do? Moves the TCP stream into or out of non-blocking mode. This will result in read, write, receive, send operations becoming non-blocking. That is immediately returning from their calls. If the operation is successful, a key is returned, and no further action is required. If the operation could not be completed and needed to be retried, the error will be would block. Okay, so we'll have to check the error and see if it's would block, and in that case we assume that the data is not available yet, right? So something like that. So makes sense to me. Makes sense to me. So we're draining all of the events in here, right? So we're just simply draining all of the events in here. In here, we can try to read something from the stream. So to read something, we probably need a buffer, right? So let's introduce a buffer. So usually the size of the buffer that I use for this chat is 64 bytes, right? So let's put it this way. It's gonna be 0, like 64 zeros, right? Like this. Stream read, and I'm just reading the buffer, right? It's gonna be mutable. I think I didn't declare it as mutable. Yeah, I didn't. So let's actually do mutable, not met. Mutable. Stream read. So in this entire thing, we're gonna just unwrap it like so. And not really unwrap it, right? So it may be an error, right? So it may be an error. So we can match this entire stuff, right? And if it's okay, right? If it is okay, we know how much we read, right? I know that read returns you how much it read. What we can do, we can just take a buffer, and we can take this amount of things, and we can turn it into a string, right? I think you can do to string, and we're gonna append it to the chat. So we're gonna just do push, like so. So we have push. Okay. If it's an error, we should check its kind, right? So it's a result, an error. I remember that IO error has a kind. Yeah, there we go. So it has a kind. So that means we need to check maybe if error kind equal, maybe not equal, error kind would block. So they said that the error kind is going to be would block. Would block, yeah, it does exist. Would block. If it is not that, I suppose we can panic, right? So I suppose we can panic. Doing something like this, I don't know, it's just something like error. Come on. So otherwise we can accept that. And that's basically it. So another thing, when you press enter, we add that thing to the chat, but on top of that, we need to send that to the server, right? So we also need to send that to the server. So let's go ahead and do that. So stream write prompt, and I can just take that. Well, I mean, I need to do as bytes, right? I'm sending the bytes. I am sending the bytes. Panicking and on IO errors, exactly. Panicking on IO errors. I'm gonna unwrap this entire thing as well. Though panicking here is not particularly great idea because we can end up with the terminal in a not particularly great state, but I don't care, right? So I'm just prototyping this entire thing. So let's go to the compilation errors. Chat push. It's actually yeah. So this is what I wanted. What else do we have? Error kind is not available. So I suppose error kind is available in stdio. So let's just include it in here. Error kind. What else do we have? Read. No method named read, and this is because we need to import IO read. So we have write, but we also need read. What else do we have? Okay, so this expression has type useSize, expect useSize, but found. That is bizarre. That is bizarre. What exactly is going on in here? Because I would expect the read thingy, read, where is the read? To just return, yeah, I would expect it to just return that. Oh, because we unwrap, we should not unwrap it, okay. Yeah, so it was just a reflex. So toString, so this has to be a pointer. You know what? So this is the stuff. We have to do something like str from UTF-8. I think that's one of the things, and we're gonna unwrap this thing as well. So what is it saying? Okay. From UTF-8, it returns str, but we want to have a string. Associated from str, bunch of, it's std, str. Okay, and this thing should be mutable. I feel like that is it. I feel like that is it, basically. So I don't freaking know. We can test it now. So let's start the server. Just a second, I need to move to the same folder. Let's start the server. So this is gonna be cargo run bin server. It's like a bin chilling, but bin server. So honestly, oh, that's fine. So let's do cargo run bin client. Okay. Hi. Hello. The fuck? Okay, that's very interesting. So first fucking try. Why was it so fucking easy? Just a second. So I need to go back in here. So here is the token. I want to start another cargo run bin client. All right, so it waits for the token, so we can put it in here. And so let's see. Oh yeah, okay. Hi. So, and yeah, essentially you can type while you do this thing. It fucking works, right? And interestingly, I think it's going to, yeah, it's, oh, that's bad. All right, so it starts like, yeah, returning things. It's a classical mistake in here. It's a classical mistake that I've already done before. I'm glad that I actually checked for that. So stream and wrap. All right, so we can do n. And what we can do, if, no, this is right, so stream read. If n is greater than 0, we're just pushing that. Otherwise, like this, because it's an end of an input. So here's the classical question that I get. Let me answer it. Do you have a video or page where you describe your setup, like keyboard layout, Emacs, key bindings, i3 settings? No, because I am a programming channel, and this has nothing to do with programming. That's the first lesson for you. All right. So what else do we need? So let's actually test this kind of stuff. So this is going to be the server, and so cargo run bin client. Okay, so now if I kill the server, okay, so it quits because it reached the end. It reached the end, and we have to provide the token. So I wonder if copy pasting from the TeamUX is going to work. It works. So I didn't really know how exactly copy pasting in TeamUX works, but I suppose it translates the characters into a sequence of keys, right? So it translates into a sequence of keys. So I think that makes sense. So welcome to the club, buddy. So another interesting thing is that when your message got rate limited, it's still added to your, you see? So the messages are added faster than the server logs them. Look at how quickly I add them, and look at how quickly the log of the server moves. Right. So essentially, to be fair, we don't really even know whether our message got rate limited or not. So the server doesn't tell us. Maybe this is something to work on, right? This is something to work on and like extend the protocol so the server can tell us whether the message was delivered, right? Or the message was actually discarded, so you don't add that message to your own log, right? To your own log. So that's pretty cool, I think. That's pretty cool. So to be fair, I don't really know how well it is going to all work. We can try to test and DDoS that. Right. We can try to test and DDoS that and see how it's going to perform. So first thing we need to do, right? The first thing we need to do, we'll need to commit all of that, right? DDoS ready, right? DDoS is ready. DDoS is ready. So yeah, let's just go ahead and see. So this is the stuff. Yeah. Implement the client. Implement the client. So it didn't. Okay. Implement the client. The simple client. Right, I'm gonna push that right into the repo. So you need to have a Rust installed on your machine, right? So if we want to be able to use this kind of thing, you need to have Rust installed on your machine. So here's the source code and everything, right? So it's already kind of pushed in there. Okay, so let's actually SSH to your mom, right? So let's go ahead and SSH to your mom. So TeamUX, I don't have a TeamUX in here, right? So let's go to for at. All right, so this is that, and let's, do we have anything? So this is the status. I'm gonna check, actually reset minus hard. All right, I'm gonna fetch prune origin master. It's actually main, I keep forgetting, right? Reflexes. Git merge origin main. Okay, so let's try to build the entire thing in maybe in release mode. Right, so we're gonna start with the release mode. So that primarily builds the client, right? So we're also building client on the server, which is not particularly neat, honestly. But yeah, that's fine. Oh, IP is hardcoded. I'm sorry. Just a second. Yeah, we need to fix that super quick. Well, I mean, you have a source code. Just fix it yourself. All right. So how are we gonna be doing all of that? So it's just building. Why do you have to do everything myself? So where is the source code? Where is the source code? I think it's in environment, right? So it's environment args. Right, yeah, environment args. Use std-env. We can do something like that. So it's gonna be let mute args. So how do you do that? Okay, so env args. So the first thing we can do, we can take a program and just do args next expect program is available. So let's just call it program name. Okay. So then we can do if let some IP, right? Some IP args next. So you can provide the IP. And if IP is provided, we can just return that IP. Yeah, just return it. Otherwise, we can crash. And what can we say? We can say eprint ln. I'm pretty sure there is an easier way to do that, like unwrap or else. Yeah, unwrap or else. Let's actually do unwrap or else. Unwrap or else. Right. Can we just unwrap it? Yeah, so since it's a prototype, fuck it, okay, so, just unwrap it, right? So if we didn't provide, it's gonna crash, so that's fine. So now here, we're gonna do something like IP, and it's gonna be format. I'm gonna, after the stream, I'm gonna go through all of these things and I'm gonna fix up all of that stuff. Okay, so we can do expect, yeah. So Muhad suggesting a pretty cool idea, right? So just say provide IP map. I didn't even notice that. Provide IP map. All right, so let's do that. Provide IP map, sure. So we can do it like that. So I swear, I promise that after the stream, I'm gonna go through the entirety of the source code and I'm gonna replace all this unwraps. I swear. This is a temporary solution. This is a temporary solution. Okay, so what do we have in here? So program is not really used, so I think it would make sense to actually do it like that. So let's actually test all of these things locally, right? So doing hat, and this is going to be the server. So we do the server, and then the client, right? So provide IP mf, right? How can I do that? 27001, boom. Okay, we successfully connected. So then it says who connected, and then boom, boom. Hi. Yeah. So one of the things, by the way, there is no editing whatsoever. If you fucked up your message, you can't press backspace or anything. I'm sorry. Okay, I can implement one quality of life feature, but that means temporary. Like, I literally implemented this thing in front of your eyes in 2 hours, right? Without even knowing this library, so cut me some slack, all right? So I can add a little bit of the quality of life feature. If you press escape, okay, if you press escape, I can clean up the prompt. Deal? How about that? I think that's the best I can do right now. Okay, right now, because implementing proper editing requires like special things, right? So it's gonna be prompt, and we're gonna clear the prompt on escape. Sure. So it's sort of like disable this entire thing. So is it something else? ESC. Boy. So let's actually test all of that stuff. So you fucked up. Press escape. It doesn't send it. It just like cleans it up. Right. So that's pretty cool. And yeah, invite to, and it even closes automatically because it closes the socket. So that's actually very useful. Invalid token breath. So Yesu. Okay, let me take a look at this thing, and I'm gonna take the token, le token, put it in here. Hi, that's pretty epic, and it disconnects. Okay, that seems to be cool. So let's actually have this as separate commits. So this one is going to be unhardcode the IP and clean the prompt on escape. And I'm going to push that right into the repo. All of that stuff is available. All of that stuff is available. Should be available. Is it available? It's still pushing, right? Okay. So let's fetch the latest stuff. Origin. There we go. So merge origin main. Okay. So and let's do rebuild one more time. Okay. So that was full rebuild. I hope that was the full rebuild. Yesu. Okay, so I have to actually prepare everything. So just give me a second. Give me one goddamn second. So this is going to be Tsoding. And this is going to be chat. So what I'll have to, well, I mean, it's hat. Cargo run bin client. And we need to take a look at the IP. SSH config. So that's the IP. Right, so that's the IP. So I need to have this window sort of like prepared so that I can press the enter and stuff like that. So let me see. So now I'm going to run, I suppose, the server. Chat, check the secrets. Hi. Oh, is it better? Is the chat experience better now? Okay, say more things, chat, please. Okay, so because I need to wipe out the token. Right, thank you so much. Okay, so hi. So, okay, we have a little bit of new lines in here. I do realize that, but that's fine. We have a little bit of new lines. That's much better, right? So even with new lines, that's much better. That's so cool. So again, it's like rough around the edges, right? It is rough around the edges. I don't understand it. I literally slapped it in 2 hours using a library that I never seen before. But I mean, I've seen ncurses before, but right? So it is so cool, isn't it? So ooh. Yeah. Okay, I'm gonna call it a success. I guess I'm gonna call it a success. So now we have more or less usable client, right? So that is better than Telnet. So we can continue working from there. Okay, so I'm gonna press Ctrl+C. And everyone should get disconnected. Everyone got disconnected, hopefully. So fine. That was actually pretty cool. All right. That was pretty cool. I guess I'm gonna call it a day. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on next recreational programming session with Azuzin. Love you all. Mwah!